Our last example, I rejected the idea that mu antioxidant equals 80, but since I don't know the mu antioxidant, I can never know for sure that my conclusion was correct. Just because my sample mean is unlikely under the null hypothesis doesn't mean it's impossible. So I have to acknowledge that I might be wrong. And there are two types of errors, It's kind of straightforward, There's a possibility that okay, in our last example, there are two things that could have been true in the population. Okay, one, there's no effect of antioxidants in the population. Two, there's an effect of antioxidants in the population. And we don't know which is true, but we have data refuting the null hypothesis, and we rejected null and concluded that there was an effect. However, what if the null hypothesis is actually true? And rejecting it even when the null hypothesis is true. That's reject the null hypothesis when it's true. That's type 1 error. I mean, and because we rejected the null hypothesis, it is possible that we made a type 1 error. It was possible in the last example. Okay. And if someone asked you the probability of making the type 1 error, it's actually the p-value. It's going to be the or alpha level is going to be the possibility or probability of making type 1 error. If we use an alpha level of 0.05, this will happen 5% of the time, because we're rejecting the null hypothesis 5% of the times, and the possibility that we do that when it's actually true is 5%. I don't know, is that really the case? Well, I mean, it's gonna be the case. So our alpha level tells us the probability that we'll make a type 1 error. Okay. So if alpha equals 0.05, there's a 5% chance you falsely reject the null hypothesis, at least. Could be more, or less. That is me. Okay. One way to think of this is that 1 in 20 independent statistical tests concluded at alpha equals 0.05 will result in a type 1 error. And there's type 2 error. Type 2 error is about alternative hypothesis. No, it's I mean, not that. Okay, type 2 error is when you fail to reject a false hypothesis. Okay, so you say you say I failed to reject the null hypothesis when you could have rejected it. In other words, hypothesis is that there's no effect. There's no effect to null hypothesis, and we failed to reject it. So we concluded that there's no effect. But the truth was there is some effect. There's some effect but we didn't reject it. So that's type 2 error. Okay, so type 1 error is, easy way to distinguish type 1 and type 2 is, type 1 error, when there's research, about medicine or something, trying to make some positive effect, and assuming there's no effect, it's probably more conservative, safer thing. If we decided that there's no effect, we're not gonna, prescribe the medicine to anybody. So it's safe, it's not, it's like a more coward, or conservative side. Type 1 error is gonna be on a safe side, but making type 2 error is gonna be more serious because, we should have said there's no positive effect, but we failed to reject it thinking there was some effect, and the chances are we're gonna actually use that prescription or intervention to someone thinking that it actually makes it better or something, but it doesn't, reality. So it's a waste of money. Sometimes it's hazardous to health, maybe. So keeping that null hypothesis, oh wait, keeping the null hypothesis, type 2 error is for keeping the hypothesis. Oh, so type 2 error is safer actually. Type 2 error is keeping the null hypothesis. So, no effect, so we're not going to do anything. Type 1 error is going to be the problem because we're not keeping the null hypothesis, rejecting it when rejecting the null hypothesis when actually there is no effect in reality. So making the null hypothesis, rejecting the null hypothesis, there's no effect. So not keeping the hypothesis means, rejecting there's no effect, so assuming there's some effect. When you think there was positive effect and you do something, and when there's no effect, it's a waste of a lot of money. So type 1 error is more serious, I guess. Anyway, type 1 and type 2 errors, there are two errors like that. So actual situation in, type 1 error, there's no effect actually, but we thought there was some effect, so possibility is, we're gonna use this method, intervention, spend millions of dollars, for example, and or giving the medicine to people. What if there's negative effects? People are gonna get sick, or spend a lot of money. Companies gonna spend a lot of money for no results, and maybe they're gonna go broke. So type 1 error is gonna be serious. Type 2 error is, actually, type 2 error is not keeping the hypothesis, failing to reject it, so no effect. We're keeping that the hypothesis that there's no effect, so we're not going to do anything. There's an intervention which is actually effective, but we're not going to use it. So financially speaking, it's not gonna cause any loss, but research wise, in terms of research and development, making a false conclusion is gonna halt the progress of research. So because it could have been a breakthrough, a major breakthrough, like a Rogaine, for example, or a Viagra. If we made a type 2 error and concluded that there's no effect in keeping failing to reject the null hypothesis, and thinking that the null hypothesis, keeping it, it's true and keeping it, no effect, no hypothesis, then Rogaine or Viagra wouldn't have made into the market, so people couldn't have enjoyed the benefit of those, but at the same time it has no financial implications or loss. I mean, you may not make profit, but there's no loss from making a type 2 error. Okay, so anytime you reject the null hypothesis, it is possible that you've made a type 1 error. Anytime you fail to reject the null hypothesis, it is possible that you made type 2 error. And you would never know for sure if you made one of these errors because you don't know the population parameters. And that's something you need to acknowledge.